Hi, I like math. I know, sue me for it. Of course, it can be very frustrating and tedious at times, but I do think it's also very fun to recognize all of its patterns. Now, you've read the title of this video. Today, I'm going to teach you how to recognize a special kind of pattern, the ones found in multiples of 3. A good amount of you probably know the easiest way. I said it in the thumbnail. If you're trying to recognize a multiple of 3, just add up the digits. If you add the digits of a number together, and those digits add up to create a multiple of 3, then the original number is also a multiple of 3. And if you're unsure about whether or not the number created is a multiple of 3, you can keep adding down until you get a 3, 6, or a 9, which are all easily recognizable as multiples of 3. This method also works for 9 as well. If the digits add up to 9 or one of its multiples, then that original number is also divisible by 9. Now, this is not the method I will show off today. I feel like this adding digits method is easier to grasp than what I'll show today, but harder to apply if you're not great at quick mental math. What I'll show off today in this video is harder to grasp than the adding digits method, but once you do understand it, it's, in my opinion, kind of easier to apply. So first, to get introduced to this method, we need to establish 3 base rules. These rules are helpful to understand and remember as we talk about how this new method works. We actually just went over base rule number 1. The digits of any multiple of 3 will add up to create another multiple of 3. I'm not going to explain it again. Base rule number 2 is a result of rule 1. Since the digits of any multiple of 3 will add into another multiple of 3, that also means that if you rearrange the digits of any multiple of 3, you will get another multiple of 3. This is because of the commutative property of addition, where the order in which you add numbers doesn't matter, you'll get the same sum regardless. If a plus b equals c, then b plus a equals c. This rule will be important to remember because this method of identifying multiples of 3 is based on the digits that make up the number. The order of the digits doesn't matter at all, only that all the required digits are there. So if 723 is a multiple of 3, then so is 237, 372, 732, and so on. Now, base rule number 3. Don't sleep on this one or else you might be lost for the rest of the video. Essentially, each single digit number can be separated into 3 different sets. These numbers are all categorized as they're all plus or minus 3 of each other. The numbers 1, 4, and 7 are all one set, and we're going to call it the 1 set. The numbers 2, 5, and 8 are another set, and we're going to call it the 2 set. And the numbers 0, 3, 6, and 9 are all one set, and we're going to call it the 3 set. The reason each number is categorized into a set is because for the sake of this theory, they're all synonymous to each other. If there's a number that is a multiple of 3, and you replace one of its digits with another from the same set, it's still a multiple of 3. So if 684 is a multiple of 3, so is 654, 687, and 384. If you wanted to, you could replace all of its digits with other numbers from the same set, and still have a multiple of 3, but at that point we've Shipofthesiused our number. And this makes sense because the numbers in our sets are 3 apart. So all we've really done is added or subtracted a multiple of 3 from our original multiple of 3, which would of course get us another multiple of 3 because of the definition of multiplication or just math. This works for any multiple of any number. You can add or subtract a multiple of 7 from a multiple of 7 and it'd get you another multiple of 7. Okay, now that we have all of that down, we can get into the fun stuff. Well, fun by my definition. I will say though that I am not the best with words and I do find this method sort of tricky to explain, so hopefully my visuals get the point across. Like stated earlier, this method of identifying multiples of 3 is based on recognizing the digits that make up the number. So it'll go like, if this number has a digit from X set and a digit from Y set, then this number is a multiple of 3. It'll make more sense once we get into it. We have to go by the number of digits when identifying multiples of 3 through this method, and it's pretty easy to start with single digits. If the number is in the 3 set, so if it's a 3, 6, or 9, then it's a multiple of 3. I guess this would also make 0 a multiple of 3, but then technically 0 is a multiple of every number, but I think that leads to a math debate that I'm not here for. That's easy enough, but it's also important to note that this makes the 3 set our special set. I'm sure you can guess why, but you'll see why in a bit. When identifying 2-digit multiples of 3, either both digits are from the 3 set or one digit is from the 1 set and the other is from the 2 set, or vice versa. See how the 1 and 2 set are sort of interchangeable in their case? There's nothing for just having the 1 set or just having the 2 set. As we go on, you'll find that in a lot of cases, the 3 set tends to get like singled out on its own, and the 1 and 2 sets get paired together. In all cases, if a number only has digits from the 3 set, then it's a multiple of 3. This makes sense, as we've established earlier. If you keep adding multiples of 3 together, you'll just get more multiples of 3, and thus your original number is a multiple of 3. A number solely composed of numbers from the 1 set or solely composed of numbers from 2 set is only a multiple of 3 when the number of digits are a multiple of 3. This is because you're adding these numbers together 3x amount of times, or in simpler terms, multiplying it by a multiple of 3, and then just adding or subtracting another multiple of 3, which would get you another multiple of 3. I'll restate this going forward, but it's still important to mention and keep in mind. Anyways, moving on to 3-digit numbers, this one is also pretty simple. A number is a multiple of 3 if it's solely made of numbers from a single set, or each of the digits are from each set. I've explained why the first rule works, but what about the second case? Well, a good way to think about it is to refer back to the rules for identifying 2-digit multiples. A number is a multiple of 3 if one digit is from the 1 set and the other is from the 2 set. If we multiply that number by 10, we'd obviously still have a multiple of 3, as multiplying doesn't remove any factors. Adding a number from the 3 set, or a multiple of 3, would of course get you another multiple of 3. And if we go back to base rule 2, digit order doesn't matter, so you could scramble that number around and get another multiple of 3. All very cool. Recognizing the base rules and how to identify 2 and 3-digit multiples are kind of the core of this method. We're going to keep going up to 7-digit multiples just for the sake of it, but honestly, as long as you remember the base rules, those 2 reasons I explained for why they make sense, and how to recognize 2-digit multiples, you're fine to apply this method all the way up. But let's keep going. 4-digit numbers are when we start using if-thens. First, a given. A 4-digit number is a multiple of 3 when it's solely made of numbers from the 3 set. If 3 of its digits are all either from one set or each from different sets, then the final digit is from the 3 set. If 2 of the digits are from the 2 set, then the other 2 digits are from the 1 set, as well as vice versa. And if 2 of its digits are from the 3 set, then the other 2 digits are from each the 1 set and the 2 set. You can see the rules for identifying 2 and 3-digit multiples here. The if 2 of the digits rules are based on the rules for identifying 2 digits, and the if 3 of the digits rules are based on the identifying 3-digit multiples, for the reasons I described earlier. So, 5-digit multiples. The rules get more wordy and elaborate here, but we still use our same reasons as before. If it only has numbers from the 3 set, it's a multiple of 3. If 3 of its digits are all either from the same set or all from different sets, then the other 2 of its digits are either both from the 3 set, or one is from the 2 set and the other is from the 1 set. If 4 of its digits are all exclusively from the 1 set, or all exclusively from the 2 set, then the final digit is from the opposite set. If you're wondering why I didn't state anything like if 3 of its digits have X quality then the other 2 have Y quality, it's because at that point I'd probably be restating a rule just with different words, and that just wastes time. Again, we're using rules from the previous digits to identify 5-digit multiples. You can see that if we break up these larger multiples of 3, we just get smaller, more easily recognizable multiples of 3. It's helpful to find these as it can make it easier to recognize the larger number as a multiple of 3. On to 6-digit multiples. Since our number of digits is a multiple of 3, the number will be a multiple of 3 if it's only made of numbers from a single set. If 3 of its digits are from the same set or all from different sets, then the final 3 digits are all from the same set or all from different sets. If 4 of its digits are from the same set, then the final 2 digits are each from the other 2 sets. I don't really need to say what happens if 5 of its digits are from the same set, because then the last digit is just from the same set, which is just a restating of the first rule. I don't think I need to do anything for if 2 of its digits are X, then Y, because at that point I think you can just try to identify 1 or 2 more digits to identify a multiple of 3. And finally, identifying 7-digit multiples of 3. If it only has numbers from the 3 set, then it's a multiple of 3. If 6 of its digits are all from the same set, and the last digit is from the 3 set. If 3 of its digits are all from the same set or all from different sets, then you can check the rules for identifying 4-digit multiples to check the last 4 digits. And finally, if 4 of the digits are all either from the 2 set or 1 set, then 2 of the digits are from the 3 set, and the final digit is from the opposite set. We're going to end it there because I could keep going on, but at the end of the day, the rules will just get more and more needlessly complicated for saying functionally the same thing over and over. You saw how convoluted that last rule was, and the one before that had you refer back to previous rules. As you go larger, it's better to break up the numbers into smaller numbers that are much easier to recognize as multiples of 3 and refer back to previous rules. And you can be confident that the original number was also a multiple of 3 because of that reason I mentioned earlier about multiplying a number by a power of 10, not taking away any of its factors. You might have to rearrange the numbers before you break it up, but you can still be confident that it will still be a multiple of 3 because of base rules 1 and 2 and the commutative property. Those are the big takeaways I want you to get from this video. Hopefully now recognizing multiples of 3 will become a little quicker for you, or maybe I've made it hopelessly more complicated. I did say near the start of this video that this method is easier to apply, but maybe you're thinking otherwise, claiming that it's too many rules to memorize to be easier than simply adding up the digits. But I don't know, I've been pretty familiar with these rules for a while, and it's made identifying multiples of 3 pretty simple. Of course, it's not a very widely used skill, but it's very neat to have. If you're having trouble with recognizing the digits, try color coding them and see if remembering the colors and how they fit together is easier to remember than the numbers themselves. Or, it's always just easiest to use a calculator. Well, I don't know, I thought this was cool. I think multiples of 3 are cool. I've been sitting on this video idea for about 2 years now, and I've been sitting on the idea itself for even longer. So calm some worries. No, this is not becoming a math channel. I want to talk about what I like on this channel, and that happens to include math, so here's a math video. I'll be back to video games in the next one. It should be the updated Splatoon brand video that comes next, if all goes well. I've added percentages to the stats this time, so that'll be fun to look at. After that, who knows, because I definitely don't. But other than that, thanks for sticking till the end, and I hope that you have a nice day.